All right. Very good evening, everybody. If you can all hear me, please say hi. If you can all hear me, please say yes instead of hi. That would be much better. Please do say yes. Okay. All right. Looks like you all can hear me. How's everyone doing? How are you all? How's it going, everyone? Yeah, long time. Yeah. How's everyone doing? Slightly new setup, everybody. Slightly new setup. So just bear with me if you guys find anything weird or awkward. Yeah, so this is the kind of thing. Hold on, just give me 1 second. Some issue with the new camera. 1 second. Yeah. Okay. Yep, now it's better. All right, so facing just a minor set of issues on the new camera, but otherwise all good. Okay, can you all hear me, see me? Are we all good to go? So we're saying going well, trying hard with HackWithInfy preparation. That's the spirit. Keep trying hard. It is it's a tough test, right? So it's a tough test. How are you guys? How's your preparation? Somebody's asking, how am I doing? I'm doing great. Thank you so much for asking. I'm doing great as well. Trying to just stay safe. I think the pandemic's almost over, I guess. But anyway, let's not comment on that. We never know what will happen. But yeah, just trying to follow all the precautions and trying to make the best experience for all of you in terms of the Edyst platform. All right, so we'll wait a couple of minutes. I think more people are joining in. So we'll just wait to see how things are going around. Okay, super. All good. Okay. So, right, everybody. As I mentioned, this is a sort of a new setup. So if you find any issues, just let me know. Feel free to message me as soon as you figure out that there are some issues, basically. So do let me know as soon as you figure something like that out. Okay. So let's take some of your doubts and questions, and then I'll start with the session. So I'll just give you the agenda of today's session. So agenda. Number one, so the major agenda is to solve some of the previously asked questions that have come in HackWithInfy, specifically the ones that came in the national mock test that we had conducted. And there is this question called KBig. Would want to solve that with you guys first. Then apart from KBig, would also want to solve pair of bishops attacking each other. This is not specifically a previously asked code vita question, but it's similar to the ones that have been asked. Code vita, I'm saying HackWithInfy questions, but it's similar to the ones that have been asked. And finally speaking, we will discuss particle simulation. We're going to discuss particle simulation here. We may not actually do it, but we'll discuss it. And I'll give you all some time to do this one. Please do check it out by tomorrow. And we'll discuss the entire solution of particle simulation as well by tomorrow. Okay. So these are the things that we're going to do. But before that, I just want to just solve some of the your basic questions / doubts. Okay. So let me just take some of those. So basically your basic questions, right? Somebody's asking, is graph important? Right? Is graph important? Generally speaking, it's important, yes, for question number 3. So for question 3, it's important. I'll just guide you to some tutorials on the Edyst platform for graphs specifically, so you guys can go through them, and we'll do a couple of questions that are kind of important. Specifically in InfyTQ, you would probably find things like MST. That's an important part for graphs. So if you just want to for HackWithInfy, if you just want to revise, I think MST is a good thing to revise on. That's what I would suggest, right? So I believe that's minimal spanning tree in graph. So that's what is what I would say. So revise that part. If you guys didn't understand at all what MST is, don't worry, I'll cover it up in tomorrow's session as well. I'll just give you a brief primer. Somebody asks, what type of question were asked in HackWithInfy 2021 and the cutoff of previous year? So I'll tell you this, the cutoff generally, as per experience, if you don't quote me on this, but as per experience, the cutoff is generally 1.5 questions. Generally speaking, that is, if you get at least 1.5 questions, even sometimes 1.25 questions, you'll at least get a call for the interview in the next round. If you got all 3 questions correct, then it's amazing. Like if you get all 3 questions correct, then superb. like you're definitely going to get called for the next round. So that's another thing. Sir, I have InfyTQ advantage round. Can I give HackWithInfy? No, I think you're not supposed to give HackWithInfy if you've already given InfyTQ advantage round. So you're not supposed to give the HackWithInfy if you have given the InfyTQ advantage round. Just do check out in their official email. You'll be able to find out from that itself, right? The DP and backtracking logic seems tough to get. The logic how to become better. You can get better by actually understanding DP and backtracking in detail. This is why we do the data structures and algorithms course. The student asking me specifically, you just have to do a lot of practice on data structures and algorithms. That's mainly it. So the DP and backtracking, lots of practice and understanding the patterns. That's super important. So I think I think Devang sir has covered a bunch of DP and backtracking type of questions. Just try to understand the pattern, right? Just try to understand the pattern on it, and that will help you out. So what do I mean by pattern? So there are certain keywords that help you kind of figure out if it's going to be backtracking or it's going to be DP or things like that. So that's what I would suggest. Important topics, most important for advantage round. So if I were to talk about advantage round specifically, if I look over here for advantage round, same as HackWithInfy, I would say. It's almost the same as HackWithInfy. I don't think it's any much different. So same as HackWithInfy. How do I know the important topics of HackWithInfy? Just check out our YouTube channel. And in the YouTube channel, you'll find I've done a roadmap to HackWithInfy sessions. You'll find all the important topics of HackWithInfy. So I would just say, and check Edyst YouTube for roadmap to HackWithInfy. You'll find all the topics discussed over there. All right. I see a bunch of people on YouTube, by the way. Please hit the like button. If you're watching on YouTube, please do hit the like button so more people can find out about this. We are on 33.4 thousand subscribers. Can we get to 35,000 subscribers, everybody? 35,000. Do help us reach that. All right. Let's look at some other questions. Got a mail from HackWithInfy a week back saying that generally the third question is of DP. So if I had to kind of put it right, it's not so much the third question. Do remember that you'll have 3 questions and they will be easy, medium, and difficult. But it is not that they are in that order. So that is, can be jumbled. It could so happen that the difficult question is your question number 1 and the medium question is question number 3. It is very much possible. They like to play around. So first go through each question very quickly and try to understand the level of each question. Right? That's something that's very important to do. So first just try to understand the level and then only go for the questions. So that's one thing. Second thing is, in easy, generally you'll find questions of strings, arrays, maths. Okay. Medium, you will find a little bit of maths, like advanced maths, DP you'll find, but a little bit basic DP, and backtracking you'll find here. And by the way, you could have maps here as well, like that's your dictionaries or maps. Same here, maps. And in advanced, you'll generally either find a DP, backtracking. Graphs are rare, but it's a bit rare though. So graphs are there, but they're kind of rare at that point. Okay. But yeah, it could just be asked. My suggestion to all of you would be to make sure you do at least 2 questions. Generally speaking, last year, if you did 2 questions, right, you're very good to go. What about BST? Honestly, I've not seen too much of trees being asked by HackWithInfy. I checked a lot of questions, but trees, generally speaking, has not been asked that much. Okay, so yeah, that's one thing. Okay, all right. Any other such? Okay, I've got 3 problems correct. Awesome. Okay, if you got 3 problems correct, that's great. Okay, you might be talking about the national mock test because on the actual HackWithInfy, it's not happened yet. So, but yeah, if you got 3 more questions correct on actual mock and on the national mock test, and you've never seen those questions before, then that's a very good indicator. You're in a very good position at this point. The ones who are qualified to advantage round, it is optional to write HackWithInfy, or we must not write. Can you please check out their official communication on this one? Check out their FAQs. I do not want to tell you anything that later on, misguides you. So I would not want to say anything on that front. Just check out their official official FAQs. They'll be able to tell you. I haven't received the round 2 email as some of my friends have received it today. Will it come later? It could come later. I would not be the right person to ask on that. right? Sir, I failed in advantage interview round. Is there chance for certification round interview? Yeah, there is chance. Even if you fail an advantage round interview, they might still consider you for a certification. So that's possible. All right, cool. Any other like basic non question related questions, and then we can go into the question, right? So any other such questions? Any future program to get job in Infosys? I think this will be it. Depends on how many people they are actually able to hire this time around. But they have a lot of openings. So, but last 2 years they've just done this in PTQ, HackWithInfy, and that's it. Is advantage round better than HackWithInfy or vice versa? I believe HackWithInfy would be better, but I think through advantage round they will get you at the same level as HackWithInfy. So that's what I would say. So it's kind of the same. Advantage round pattern, advantage round exam pattern in PTQ. So for advantage round, is the same as HackWithInfy. Do check out Edyst YouTube roadmap to HackWithInfy. Sir, time duration of the exam 3 hours. For better time management, how much time we should spend on it? So, okay, so first of all, go in with the assumption that I want to solve just 2 questions. Don't even bother trying to get to 3 questions, right? This is my advice to most of you guys. Because in your quest to do 3 questions, you will end up not doing all of them properly. So my advice would be try to do 2 questions only. Don't try to do more than that. Just try to do 2 questions, okay? And in those 2 questions, try to spend the first 1 hour doing the easiest question. That 1 hour, generally speaking, will be a lot as well. You don't even need that much. So my time my time management strategy, and again, I'm talking about for most users here. If you are a student who's already like doing code forces, lead code, that kind of level, and you're already great at DSA and so on, feel free to attempt however you guys are attempting. But those people who are I know the general people, right? So in those cases, if you want to do a time management strategy, the best way I would say is spend around whatever 20 to 40 minutes, depending on how much you can, on the easiest question. Okay. I have seen students, even with like basic understanding, if you get the logic, 25 minutes you can finish the easiest question. So that's one thing. Then remaining, what do you say, 2 hours or 2.5 hours, just spend on medium question. Trust me, guys, don't even try to go for the difficult question, because if you get full marks in the medium question, you would have solved 2 questions, first question and second question, and you're sure shot to get the interview. This is my experience in the last few years. Sure shot you're going to get a call for the interview at least, right? Will you get called for the 9-10 LPA job? That's a separate story. You may or may not get. But if you get 2 questions clear, there's a very good chance. Like, again, I don't know any student who, after clearing 2 questions and no plagiarism or whatever, that they didn't get. They always, if they cleanly done, everything is not normally done. So after 2 questions, you directly get into it. So this is what I would say: 20 to 40 minutes on the first one, and the remaining 2.5 hours, try to do as much as possible on the medium question. Don't even go for the difficult question. Why do you even want to get into that, right? Code Vita is a separate strategy. Code Vita, because there are like 6 questions, open book test and all, it's a separate strategy altogether. But the time management strategy here is, this is what I would say: do the 2 questions. Your aim should be 2 questions, and that's it. This is for the general student, right? If you are someone who's cracking like hard level codes on lead code, hard level codes, on, let's say, code forces and so on, this does not apply to you. You don't need any time management strategy, as per my view. You can do it on yourself. So you don't need that. That's the thought. Okay. Sir, there any greedy question in HackWithInfy? Very few. I've not seen mainly. Do you have to write another code or function only? You have to basically start from taking the input part. Generally, you have to start from taking the input part. Sir, on lead code, I can do 70 to 80% of easy codes and 30 to 35% of medium ones. Do I stand a chance? So for you, this applies. What I'm talking about, this time management strategy, this applies to you. Follow this, you should be able to crack it. Okay. Do we have greedy for HackWithInfy and advantage round? Again, mostly not. I have not seen any such questions of greedy for HackWithInfy as such. Okay, cool. Any other such questions, everybody, or do you guys want to get started with actually solving some questions now? Any other such questions from your side, everyone? Multiple languages are allowed? Yeah. Yeah, multiple languages are allowed. Multiple languages are allowed, and yes, multiple languages are allowed. You can do one question, or you can choose different languages for different questions. Although I would not suggest you do this. Pick one language and just be good at it. That's what my suggestion would be. Is TC matters in HWI, which I think you mean to say is test case matter in HackWithInfy. Test case matters in any coding round, not just HackWithInfy, but any coding round. Okay, beautiful numbers explain, sir. So for beautiful numbers, I think we've already covered it. It's already on. If you can, I think people on YouTube are asking. Just go to Edyst YouTube channel. Beautiful numbers already. That logic is there, and even the code is there on the Edyst platform, so you can check that. So that's another thing. Minimum pluses also. Minimum pluses we have a tutorial both on the Edyst platform as well as on Edyst YouTube channel. So you can just check it out. Minimum pluses. So don't miss out on that, everybody. So both like beautiful numbers. Check out Edyst YouTube. If you did not understand it even after checking that out, I will help you out tomorrow. I'm not saying go watch and don't come back. Check it out. If you still not understand even after watching that, after reading the Edyst tutorial, then you come back. I'll be happy to help. Same thing with what is the other one? Minimum pluses. Minimum pluses. Also, I would just say the same thing. So do check that out. Does brute force work in HackWithInfy? You'll probably pass 1 or 2 test cases. I don't think that will help you at all to get cracked into the interview level. Our medium level ones are similar as lead code medium level, sometimes even higher. It's a lead code medium or sometimes even higher than that. And you'll say, sir, what is this? They are asking at level of Google, Facebook. I know they are asking at level of Google, Facebook. They don't pay you at that level, but they like to ask you at that level. So that's how they do. Okay. Cool. All right. So let's get started, everybody. Let's get started. How to deal with time complexity. You just should know the algorithm. You should know how to break down the algorithm, basically. I should know how to figure out. So we'll do one today and you'll understand. We'll do a couple of them and you'll understand over here. I've already seen beautiful numbers, but some doubts are there. Cool. So as I said at the start, I planned for these 3 questions today. But if you guys still have doubts after that, probably in tomorrow's session, we'll have a longer session. And we'll definitely take that up in tomorrow's session. So in today's class, we'll take up K-big, pair of bishops attacking each other and discussing, we'll discuss particle simulation. And can you explain the minimum string rotation? Sure, let's kind of discuss that also if possible. But let's first do these 3 because they were also asked in the mock test and they are all previously asked, roughly similar to previously asked questions. So let's first discuss these 3 and then we'll go on to the next part. Okay, we'll check the next set of questions. Okay. All right, is everybody ready? Can you all just tell me ready to start? You guys want to see some code, right? So let's do some code. So are you guys ready? Shall we start? Okay. All right, so let's start with K-big. How many of you solved this question already? K-big? Any of you saw it? Anybody saw it? Anybody solved it? K-big? Let's pick that up. K-big. Here we go. So anybody saw this question, K-big? Anybody received it in the mock test? And if so, what are your thoughts about this question? Just let me know. Anybody seen the question, not seen the question as yet? So this is directly from last year's HackWithInfy, by the way. This is directly from last year's HackWithInfy. Okay, I'm just waiting for a response. Have you seen this question? Not seen this question? No? Okay, you've not yet. It's on the platform already. You guys have not seen it yet. Okay, cool. One student says no. What about others? Have you seen it? Not seen it? Not yet seen in mock also. Okay, fair enough. Okay, so let me just zoom in a bit and show you. All right, so everybody, we're doing the question K big. All right, it's in the HackWithInfy. Is it for DSA students in the previously asked questions? It's in the previously asked questions part for DSA students, and for HackWithInfy people, it will be there below the in arrays. It's going to be there in arrays, so you can check it out there. Okay, so you're given an array of integers of length n. Basically, it's an array of integers with n numbers. Any subset of the given array is called a K big subset if the sum of all integers in the subset is greater than equal to K. Any subset of the given array is called a K big subset if the sum of all the integers in the subset is greater than or equal to K. Also, for all integers, you decide whether it is a futile integer or not. So how do we decide if it's a futile integer or not? If for any K big subset of the array containing AI, the set that can be obtained by eliminating integer AI from the subset is also a K big subset, then the AI is considered futile. Okay, so first of all, try to understand this question. Okay, this is, I won't say simple or difficult or whatever, but let's just try to understand the question, what it's saying. If for any K big subset, so there is something called as a K big subset. What is a K big subset? A K big subset is one if the sum of all the integers of the subset is greater than equal to K. So for example, I don't know, let's just take, for example, we take a subset, we take a particular subset, and if it is the sum of the integers of that subset are greater than K, then it's considered to be a K big subset. Now, the problem is not that. It's very easy to figure out if the subset is K big or not, because you can just take the sum of the integers and just check if it's greater than K or not. What is K? Where is K? And so on. That will be given in the input, I believe, right? We don't know what K is and so on, but we believe it's going to be given in the input. So we have that. Also, for all integers, to decide whether it is a futile integer or not. So the question is not asking to figure out if a subset is K big or not. Rather, it is saying there is this concept of K big. With that concept of this thing K big, you have to decide whether it is a futile integer or not. How do we define whether an integer is futile or not? If for any K big subset, we're talking about any K big subset of the array containing AI, the set that can be obtained by eliminating integer AI from the subset is also K big subset, then the AI is considered futile. Means even if there is one subset, even if there is one K big subset, such that I remove AI and I still get a K big subset, then it's said to be a futile, a useless number. Your task is to find the number of futile numbers in the given array. All right. Now, again, this might seem a little bit complicated, what's going on and so on, right? So let's try to understand here. The first line contains an integer n denoting the number of elements. Next line contains K, and then after that, it contains the number. So for instance, if I pick this up, so let me just come back. Let's just understand the input again. And this is why I'm saying, take a good amount of time to understand the question, because the question they will give you will be complicated to read, not complicated to implement, but definitely complicated to read. Okay, K big. This number is n. This number is K as per the input. Okay, this is the array. So the array that you have is this 1, 4, 3. This is the array that they have given. All right, everyone. Now the question is, first of all, is there a K big array in this? The question does not even ask that, but I want to ask you, is there a K big array? And what does it mean by K big array? A subset will be 6 big. In this case, 6 is K. So a subset will be 6 big if sum of subset is greater than equal to 6. So first of all, how many such subsets do we even have? How many subsets do we have such that the subset is greater than equal to 6? Can anybody tell me? We have 2 subsets. Okay. So we have a subset 4, 3, and we have a subset called 1, 4, 3, right? That's what we have. Sorry, again, as I said, this camera is a little bit shaky. Just give me 1 second. I'll just fix this. Just give me 1 second, everybody. All right, give me 1 second, everybody. Yeah, and we are back. Sorry for that. Just new setup. Thanks for just bearing with me. Anyways, so we were saying there are two big subsets. There are 6 big subsets. One is 4, 3 because the sum is 7, and here the sum is 8. Correct, everybody? So one has sum 7, and another one has sum 8. Yeah. So overall, there are 6 big subsets. Now, the question is not asking that. The question is saying that of the 6 big subsets, okay, of the 6 big subsets, how many of them have, or rather, how many integers are futile integers? In the sense, a futile integer is one. Futile integer is one in which, what is a futile integer? Futile integer, if you remove that integer from a k big subset, then that subset continues to be k big. So even if you remove the integer from the k big subset, that subset continues to be k big. Is there any integer like that in this array? Is there any integer like that? Very nice, very nice. As Tejaswani is saying that if I remove 1 from 143, it will continue to be k big. Very good. So if from this array, that is from this subset, here if I remove 1, it will continue to be k big. Okay. So the futile integer over here is 1. The futile integer over here is 1. We are not saying that how many subsets are there that can become futile. No, we're not talking about that. We're just saying the futile integer here is 1 because 1 belongs to a subset, and that subset can continue to remain k big even though we are removing that integer, right? So that's the point of a futile integer. Question says count the number of futile integers in the array. So how many futile integers do we have? How many futile integers do we have over here in the original array? We have only one futile integer, that is the number 1. Because if you remove 4 or if you remove 3, any of the existing k big, there is no such k big subset that will continue to remain k big if you remove 4 or 3. Okay, cool. So let's look at another example if they have given. Let's see. I think this was probably, yeah, this. So the thing is, we have taken this verbatim from HackWithInfy. This is the only example that they have given. They have not given you any other example. So see how sometimes diabolical the test is. They've given you the most simplest example that you can think of, right? They've given you the simplest example. So yeah, that's one thing here, right? Cool. Now let's try to figure out a little bit more. So let's take our own examples, right? Over here, let's kind of take our own example. Let's say the input that was given over here was something like 5, right? And let's keep that to 6 only. Okay, let's probably keep this 8, let's say, and let's see. Okay, now how many futile integers do we have? If you just think about it, how many futile integers do we have over here? What do you guys say? How many futile integers do we have here? Take up a couple of minutes and think. Okay, somebody saying 4. Can you tell me which integers are futile over here? 1, 3, 4, and 5 is what you're saying. Okay, somebody's saying 6 futile integers are there. All right. Okay, so here the n is 6 and k is 8, by the way. K is 8. Okay. Before I even start, can anybody tell me how many subsets will we even have of this? How many subsets we'll have? I'm not talking about sub array, I'm talking about subsets, meaning the numbers can be taken in any order, right? So how many subsets will we have? Very good. 2 raised to 6, we'll have 2 raised to 6, of which one of them will be a null set in itself. But yeah, 2 raised to 6, 2 raised to 6 is nothing but 64, right? So we're going to have 64 subsets. So it's impossible for me, at least in this example, for me to actually write down all the 64 subsets. You could probably write it down on your own notebook, but there are going to be 64 subsets overall. Okay. In some of those subsets, if you take out a number, it will continue to be 8 big, right? It's going to continue to remain 8 big. So what are those numbers that can be removed from those 8 big subsets? Okay, so somebody has a very interesting answer on the chat on YouTube. Make a DP table for subset sum. Very good that you know how to do that. I think everybody, I guess, subset sum, making DP table. This is something you guys should know. So make a DP table for subset sum. Very good. Check whether it exists or not. This is what you're saying. Find if that is futile or not. So, okay. Somebody's put this. I'm not saying it's correct or wrong. We'll come back to this. Okay. We'll come back to this as an approach. But let's first try to solve 1, 2, 3, 4, 5, 6. Can you all tell me what are the possible futile numbers or futile integers over here in 1, 2, 3, 4, 5, 6, given that k is 8? All right. Somebody saying 6. Okay. Others, any idea how many futile numbers? Think of it. And if you can't, then it's fine. I don't even want a logic. I just want to look at this problem and try to solve it. How many futile numbers do we have? All numbers are futile. Okay. Why would you say all numbers are futile? With different combinations of subsets, we can see that all numbers are futile. Okay. All right. So what I can kind of understand from you guys is that it is possible to make a sum 8, right? So for example, is 1 futile? Well, what I could do with 1 is, what I could do is I could have, let's say, 3, 5, and 1, right? This is k big. This 3, 5, 1 is k big. So remove 1, it's still k big. So 1 is definitely futile. Let's go to 2. I would apply the same logic. 3, 5, 2 is k big in itself because 3 plus 5 plus 2 is 10. It is greater than or equal to k. And if I remove 2, it's still k big. Okay. What about 3? I can kind of apply the reverse logic here. I can make it 5, 2, 1. It's k big. I put a 3 here. And then when I remove 3, it's still k big. Right? Then let's go to 4. Same thing. Like, so I think you guys are getting it, but I could literally do the same thing. I could say that 5, 3, 4, right? Remove 4, still k big, right? So 4 is also that futile. What about 5? Simply put, I could put 4, 6, and 5. It's k big. Remove 5, still k big, right? And 6, again, same thing. 4, 5, and 6. Remove 6, it's still k big. So can I say that all of these numbers are futile? 1, 2, 3, 4, 5, 6. There are totally 6 futile numbers in this array. Okay, somebody's asking on YouTube what is futile. Just rewind this and you'll get what futile is. Just rewind the session, you'll get what futile is. Okay, so does everybody agree with me that all of these 6 numbers are futile numbers? Are you all agreeing with me on this? Okay, fair. Still not time to go to the logic. I want to take another example. Okay, let me take another example. Let's say I have only 3 numbers. Let's say my k is 9. Okay, and I have How many futile numbers do I have over here? How many futile numbers do I have over here? So somebody saying 3 futile numbers. How would it be 3 futile numbers? Okay, somebody saying 2 futile numbers. Which are the 2 futile numbers? 3 and 5, right? So here 3 and 5 are futile, right? Totally 2 futile, right? And why is it that 3 and 5 are there? Because first of all, here I can even come up with all the possible subsets, right? And the subsets would be 2 raised to 3, 8, I'm guessing. Yeah, there 17, 5, 3 individually, and so on. So, but what I'm saying is there exists at least one subarray. So, for example, if I just take 17, 5, 3 overall, if I remove 5, or remove 3, it still is k big. It's still 9 big, right? So it's still going to be 9 big even if you remove 5. Therefore, both of them are futile. But 17, it's not at all possible to remove and still be k big. It's not possible to remove, right? Okay. So the question says you have to find out. Okay, somebody got the answer. Very nice. But can you all now tell me, can you think of a logic over here? Can you think of a logic here? How do I find out whether a number is futile or not? So this is the first step. Always try to take examples. And we've taken a bunch of examples. We've got some idea over here. With this, take a couple of minutes, but tell me, how can I find out whether it's futile or not, or how many number are there that are futile or not? Something kind of subarray. Okay. All right. Somebody's saying subarray. All right. Others, what do you guys think? Okay. So somebody's got the answer. Good one. Good one. What about others? What do you guys think? Somebody saying cumulative sum. All right. Interesting. How would cumulative sum help here? Array consists of only positive numbers. Good. I like that you're asking for constraints. Let's check it out. Does array contain only positive numbers? Let's see. So if we go here and check it. Yeah, array is all positive numbers and up till 10 raised to 9, by the way. It's all positive numbers. Yep. Okay, find the minimum subset, somebody is saying, and the remaining elements become futile. Okay, cool. So some of you have got the answer. All right. And the question, the wording is very important, right? And this is what they do. They try to trick you. If you look at subsets, right, the mind automatically goes to subset sums, right? We think of subset sums. The thinking is subset sums, and I go to DP, right? Subset sums in DP, we've all done this before. So we automatically end up going to like DP in subset sums, right? Where the question is not asking number of ways do we want to get to the subset, or is it possible to get to the subset? The question is just simply asking, is this number futile? Meaning the question is asking, does there exist a subset such that, let's say that subset is X, okay? Such that when I add element, let's say, and let the element be like some AI, or let the element be some, let's say J. When I add element J, or rather, let me just formalize it. What we're trying to say is there is some subset X such that sum of X is greater than equal to K. It's already K big. And we're saying that, does there exist any subset such that the sum of X minus a particular number that we have right now, let's say that's A, is still greater than equal to K, right? So what we're trying to say is, does there exist a subset X such that when I remove element A from it, it's still greater than equal to K? Okay. So the question is this, we are saying that first of all, we have to have that sum of X should be greater than equal to K. And when I subtract A from it, it should also be greater than equal to K, given that A is part of subset X, right? So we have to figure this out. So if you look at it, I'm not really concerned about getting the actual subset sum. I'm not really concerned about that, right? What I'm actually trying to figure out is there a subset such that which includes A, even when I remove A, it's still greater than equal to K? If there is such a subset, then I can safely mark A is futile. Are you all understanding this, everybody? Are you getting this particular point that it's asking? So again, it's easy to get caught up that, oh, is it DP, is it 2 pointers and all of that? But let's just focus on the problem again. Let's try to solve the problem. What's the problem saying? The problem is saying that, does there exist a subset X? Is there, it can be any subset X, but such that if I take A out from it, it should be still greater than equal to K. So what is the best chance that I can get such a big subset that even when I remove A from it, it will still be greater than equal to K? What is the best chance of a subset that I can get? What's the best possible subset that I can take to? It's not asking that you have to take an optimal subset or this or that. It's asking, does there exist any subset like this? Okay, many of you are getting the answer. I like it, right? What's the best subset I can take such that even if I remove A from it, it will still be greater than equal to K? Absolutely correct, guys. Awesome. If I take the sum of the entire array, awesome. So let's just take, because A will definitely be part of the entire array, otherwise it's not there. So let's assume the subset where the entire array is there. Let's take the subset where the entire array is there. Okay. And if I take the entire array, so the logic kind of comes down to like this. Okay. Take sum of ARR. For each element, check if sum of ARR minus element is greater than equal to K. If it is, right, futile plus plus. Because, but for this, we need to make sure that sum of ARR should be greater than equal to K. We need to make sure of that. So the easiest sub array, or the easiest sub array for us to take, or the subset to take rather, the easiest subset to take is the entire array. The entire array contains all the elements. Every element will be part of the subset, and it will have the maximum sum possible. So it will give us the highest chance that even if I remove the element, it will still be K big, right? That is the highest chance possible. Correct? Everybody understanding this? Right? So everybody kind of got it clear. Somebody saying they must have done a PhD in confusing students. Yeah. See, this is the thing. They try to give you subset sums and DP, and you're suddenly thinking all of this. What is the order of this approach, everybody? Can anybody tell me the order of this approach? It's order n. That's it. Subset sums and all that you have to do like order, the order sum of array and so on. It is order n. Nothing else. You don't have to do anything. So just simple logic, right? So that's what I'm saying. Like some of these test cases are just like that, right? Like there, or rather, some of these are just like you don't have to overthink it, right? Don't try to go for subset sums, this, that. Don't try to overthink it too much. That's what I'm saying. Okay, cool. So let's try to attempt this problem. What if the array contains negative ones? We'll come one by one. We'll come one by one to all of this. Okay, so let's try to figure out the answer over here. So I'll first of all do it in Python because it's a very simple pseudocode kind of thing, and then we'll do it in Java also. Don't worry on that part. Okay. If they would have given a few more sample test cases, it would have become clearer faster, maybe. Yes, it would have. That is again, I'm with you 100%. They are not trying to help you pass the test as much as easier. They just, I mean, they want you to think. It's a 3 hours test, I think, for that reason. They want you to think a lot on your own, and they have their own reasons for that. So I'm not the one that's right. Okay, I love the chat. I love the messages you guys send. Good one, man. Good one. Okay, that I cannot repeat here, but yeah, good message. Okay, cool. Let's first take the input n, and then k is equal to int input. This is the k. Okay, don't worry, guys. I'll come in the other language as well. And then we'll actually just go through all of the n inputs and add it to the array. So, ARR is equal to this for element, or rather for I in range n except all of the elements. So I'll just say that element is equal to a is equal to int of input, and we do ARR dot append element. So I appended the particular element over here, and then what do we do? That we just have to take the sum, right? So we say overall sum is equal to sum of ARR. So we can do this in Python, sum of ARR. So this is overall sum, and then I do for j in range n. I go through it and I check, and I'll keep a count of futile equals to 0. And what we'll do is we'll also have to check in the case if there are no futile numbers, right? So in that case, what first we'll check is if overall greater than equal to k. The overall sum has to be greater than equal to k. Otherwise, if the overall sum is not greater than equal to k, there are no k big subsets to even begin with, right? So if overall greater than equal to k, then great. Let's do this kind of a thing, right? Or rather, I'll say if overall is less than k, then I just or rather, sorry, we'll do this. If overall greater than equal to k, then we're doing this. Otherwise, there are no futile numbers. So I'll go through the thing for j in range n. For j in range n, if overall minus ARR of j is still greater than equal to k, if this is still greater than equal to k, then this is a futile number, and I'll do futile plus is equal to 1. Okay, and then after I'm done with this, I'll print the number of futile. So I'll print the number of futile regardless of if it's greater than k or not. So because if there is not greater than equal to k, then I'll just print 0 over here, right? Let's see, did I miss anything up? Okay, it works here. All right, fair enough. It is okay, cool. So it is, the input format was given was wrong, I guess. 1 second. Oh, one of them has, okay, the submit input cases are different from the run input cases. I see. Got it. Fair enough. Okay. Very interesting. So then in that case, it's not like this. Then ARR is equal to list map int input dot split. Okay. Submit cases are a little bit different. So then we don't have this over here. So now this one will come out weird, but this one still works. And in this case, list index out of range. So almost all passed, but in this case, we are j in range n, but it's out of index, and probably n greater than 0. In that case, that won't work, but let's just see. Okay, it's still going out of index. All right, so most probably we have not. Okay, it's still causing issue. Line 14, 1 second. N is greater than 0. Overall minus ARRJ greater than equal to K. Why would this be out of bound? ARRJ. Okay, let me just do len of ARR. That would be easier for us. Sorry, ARR with capital. It should be like this. Yeah. Okay, now it's not matching the output. Okay, something's wrong in terms of the number of elements in the array. I think there's something wrong with the test case over here, I'm assuming. Let me just try to understand. I'm getting no such element exception in Java. Yeah, I think the test case, there is a problem in the test case, I believe, over here. This test case has having a wrong input or something. I see. Okay. The number of elements in the test case are coming wrong. Yeah, I think there's a problem in the test case itself. Your output didn't match the expected output. Test case 3, 4, 5. Just give me 1 second. Yeah, I think n, which is given to us over here. Should we take long? Yeah, in Java you should end up taking long for sure. That you should definitely do. But over here, 1 second. Just give me 1 second. I'll just check it out. What could be the issue over here? Hold on. This is. Yep. Okay, cool. I'm just looking into it. Just give me 2 seconds, everybody. I think there's something up with the test case over here. Just give me 2 minutes. I'll just check it out. Second. Just checking this out. Will be updated in just 1 second over here. Okay, yeah, so looks like the test case is not up to the mark here. Just give me 1 second. I'll get that thing checked out. Yeah, there was an issue with the test case is what I'm checking. Just checking with my team. They will update me. Okay, but our logic is correct, everybody. So don't worry on that front. Logic is correct. Okay, give me 1 minute. Getting this done. Just 1 second. Yep, here we go. Okay. All right, cool. So now I think it should work. There was a faulty test case over there. Yep, now it works out, right? Okay, cool. So we just rectified that test case. It works out. So that's pretty much it, everybody. That was there's a small issue on our end, but other than that, fairly standard, fairly straightforward sort of a question. Okay, I'll do it in Java also for those of you guys who wanted to just check it in Java. So let me just take it in Java as well. Import java.io. Okay, and everybody over here, if you could just tell me in Java, what's the way of taking long in Java? So do tell me that, and I'll do the rest. So public class main is the Java part, public static void main string args. So ideally speaking, you should take long here. We'll try it with int, but we'll take long. We'll try it with int, but as per the constraints, maybe our test cases don't have that, but as per the constraints, 10 raised to 9, you should definitely take long for that. Okay, so int n, k, and you also have scan is equal to scanner system. n, right? And for int 0, I less than n, I plus plus, arr I is equal to scan dot next int, right? So that's one thing. We have to take arri also. So you have int arr equal to new int n, and we can also just take int sum equal to 0, and int futile is equal to 0 here. And we don't even need to go through the array again. We just take the sum over here itself. So this is equal to sum is equal to sum plus arri. And what else do we do? We do for int j, or again the same thing. You can just go through the entire array, but this time just check. So this time we'll basically check that if arri, if let's say sum minus arri is still greater than equal to k, then you do futile plus plus, and finally we'll print out futile. Okay, so we'll print that out. Yeah, there's also that case of, you can also just check here, sum greater than equal to k. Yeah, we just want to check that anyways the sum should be greater than equal to k, right? Otherwise there's no point in doing that. N might not have been initialized. Okay, we didn't take n in, so we should do n is equal to scan dot next int, and k is equal to scan dot next, right? That's what we should do. So that works out. And in one case it's not matching, otherwise in all cases it is matching. Let me just check. Is equal to k, then you do futile plus plus futile. What is the case that we're missing? Is that long? That's what. Okay, so all right guys, tell me about long. How will I get a long array? All you guys, all you Java guys, tell me the syntax of getting a long array. We'll just try out long. Some will also have to be long. Futile can be integer actually. If you just take the number of, yeah, futile can still be integer. Worst case scenario, it's 5,000, right? Okay. So should I just do long sum? You guys have to tell me. Right. So next long, and somebody saying I got it with int. Okay, so then I must have probably made some stupid mistake here somewhere. Let's see. That works. Yeah, it was the long issue. Yeah, so somebody got it with int. Okay, congratulations to you. But yeah, it is the long issue. It was not working without long. All right. So why did we have to take long? Because just the elements, the sum could be, there could be 5,000 elements, and each element could be up to 10 raised to 9. So it can, the sum can easily go to 10 raised to 12. Right. That's why. Okay. All right. Clear, everybody. This part is clear. K big. All cool. I don't think super difficult, right? What if you get disconnected between the exam? Do check out their FAQs. They'll help you out with that. Check out the FAQs. They'll be able to help you out with that one. Okay. Shall we move on to the next one, everybody? Okay, others, do let me know in the chat. Should we move on to the other one? I'm also seeing, like, are you guys having exams or something at this point? Because it's lower turnout than what I thought I'd get. Is it like exams or something are going on for all of you guys at this point? Because especially with mid-sems, right? Yeah, I thought so. It's a bad timing for you guys to have HackWithInfy around the same time, because yeah, it's it's a great chance to get a job. So I guess mid-sems. Okay, awesome. All right, offline classes just started. Okay, but we are doing it in the evening, right? So anyways, I think that's fine. Should we start with the next one, everybody? Pair of bishops attacking each other. Should we start with this one? Where is this question? Pair of bishops. So for DSA students, you will find this, I guess, in the previously asked questions. May not be under HackWithInfy, maybe under Google or something. I think it could be under Google. For everybody else, this is in the maps section. So in the HackWithInfy section, it's in the maps part. Let me just show you here. For all the HackWithInfy students directly, you can just check it here. Maps, pair of bishops attacking each other. And for DSA student, it's in the Google section. So yeah, we're doing a Google level question right now. But yeah, it's similar to what HackWithInfy also asks. Right. Okay, so shall we get started, everybody, with this one? Okay. So on our special chessboard, two bishops attack each other if they are in the same diagonal, if they share the same diagonal, right? This includes bishops that have another bishops located between them. That is, bishops can attack through pieces. Incidentally, how many of you play chess, everybody? How many of you guys play chess? Anybody plays chess here? Just even randomly. Okay. Should we do an Edyst chess tournament sometimes? I think, all students of Edyst once getting together for like a chess tournament. That'll be fun, right? Yeah. Because you're all anyways into DSA and all. So might just be fun to do a chess tournament. I'm not really good myself, but I just have fun playing with people. So I think we could organize something. Okay. Don't know anything, sir, about chess. Okay, great. So, but you all know at least the basic pieces of chess, like the something chess.com tournament. Yeah, let's do something. But anyways, coming back. So do you guys know the basic pieces of chess, at least? Like what's a bishop? What's the colloquial term for a bishop? Like in Hindi or in your own languages, what do you generally call a bishop? Yeah, it's the camel, right? Okay, cool. So you guys know it. Cool. That's good. So it goes basically diagonally, right? It's going to go diagonally. I always wondered why a bishop there is called a camel here, but I guess it is what it is. Anyways, so on a special chessboard, two bishops attack each other if they share the same diagonal, right? And this includes bishops that have another bishop located between them. That is, bishops that can attack through pieces, all right? You are given n bishops represented as row, column, tuples on a m chessboard. Write a function to count the number of unordered pairs of bishops that attack each other. Okay. Let's just see as an example here. So for instance, they are going to give you, and I've actually kind of made a chessboard also here. So kind of like a chessboard. So we'll get, but there are 2-3 changes over here. One is that the chessboard is m cross m. It's not 8 cross 8 like how usually it is. It's not 8 cross 8, but it's m cross m. So it can be like however big as we want, right? It could be a 4 cross 4, 3 cross 3. It could even be a 10 cross 10 or 20 cross 20, right? So it's just that it's a square chessboard, but it can be arbitrarily big or small chessboard. Number one. Two is, if there are bishops standing on a chessboard or on a diagonal, they're going to attack each other. And if there is more than one bishop there, then they will attack simultaneously each other. Okay, so just to understand that, let's kind of understand what that looks like. So just give me 1 second. Let me just see if this is there. Okay, so this is kind of like a chessboard over here. These are, and I'll just 1 second copy it here as well. Yeah, so right. So these are basically your chess like your coordinates, right? So 0 to 7 and 0 to 7. And again, this is not really the actual chess coordinates. In an actual chess coordinates, what you end up having is 1A to E4, E5, things like that, right? Basically like the row first and then the column or something. So that's how the chess notation works, but it's not how chess notation works. But we don't care about chess at this point. What we are caring about more is how it translates to our 2D array. So what they're saying is, it could so happen that there are bishops standing on a diagonal. Now, what do I mean by diagonal? So let's say, for example, I pick up just this diagonal. So I'm not only talking about like, the diagonals of a square. No, I'm talking about like any particular diagonal. So if I look at these diagonals, right? So this is at, let's say 7,1, 6,2, 5,3, 4,4. Let's say I pick up this diagonal over here. On this diagonal, let's say there are two bishops that are there. Okay. Let's say these are the two bishops. In blue, you have two bishops over here. Okay. So are they attacking each other? These two blue bishops? Because they're on the same diagonal. So will they attack each other? Yeah. So they are going to attack each other because they're on the same diagonal. Now the question is not really asking you how many bishops attack each other, but very specifically the question is asking you that the number of unordered pairs of bishops that attack each other. So the number of pairs that attack each other. And why is it unordered is because if you take this pair, let's say I take this pair 6, 2 and 3, 5. I have to take it only once. I don't take that, oh, there are two pairs, 6, 2, 3, 5 and 3, 5, 6, 2. I don't take two pairs. I take, it's only one pair. So if I've taken 2 points, they're actually only one pair that's attacking each other. Okay. So this is what I have over here. Now let's say there was a third bishop here. Let's say in the corner over here, we had another third bishop, let's say, right? So now how many pairs are attacking each other? And remember the question said they can attack even through each other. So how many pairs are attacking each other at this point? Okay, everybody try to think how many pairs are attacking each other here. Okay, a couple of people are saying 3, others 2 pairs. Somebody saying 2 pairs. Okay, let's check it out. So your 6, 2 over here, your 6, 2 at this point, if I can say, I'll just call it A, let's say this is A point, this is a B point, B bishop and C bishop. Okay, this A will attack B, A will attack C, right? So what are the pairs you have? You have a pair AB. So you have a pair AB, you have a pair AC, and you have a pair BC. You don't have a pair CA because AC already counted. You don't have a pair CB because BC already counted. You don't have a pair, let's say BA because EB already counted. So overall in this diagonal, there are 3 bishops and they will form amongst themselves 3 pairs that attack each other. All right. If let's say there was a 4th one, let's say there was a D here. If there's a D here, now how many pairs are there that attack each other? So for only 3, we had 3 pairs. For 4, how many will be there? 6. Okay. How can we say 6? Okay. So we look at it like this. We say AB, AC, right? That was usually there. And then you have AD as well, because A will attack D. Then B will attack C. I will not count, let's say. So I will not, B can attack C. B can attack C, B can attack A already counted, B can attack D, and C can attack D, right? Everything else, it's already been counted. So I have 6 over here. Okay. So on a particular diagonal, yeah, so it's 6, not 12. So it will be 6 at this point. So on a particular diagonal, how do I find out the number of pairs attacking each other? Okay. How can you find out? If you know the number of bishops on a diagonal, how can I find out the number of pairs attacking each other? Somebody saying NP4. Why 4 always? Why are you doing NP4? And what is N over here? Somebody saying NP2. Okay. Would it be NP2 or would it be something else? Somebody saying NC2. Would it be NC2? Somebody saying n into n minus 1 by 2. Yeah, it would be NC2, basically choosing any 2 elements, but we don't care about their permutation. That's why I'll not go with NP2. The reason I'll not go with NP2 is I don't want BA after that. If I've done AB, I don't want BA after that, right? See, if I look at this, for example, in the example they've given, you have one over here. Let's look at the exact example that they have given, right? So 1, 1, 2, 3, 3, 3, and 5, 1. 1, 1, 2, 3, 3, 3, and 5, 1. So they have said, and I'll just mark it in red. So let's say 1, 1, 2, 3, 3, 3, and 5, 1. Right. So these are the ones that are there. So I believe 1, 1, and 3, 3 share a diagonal. 5, 1, and 3, 3 also share a diagonal. But 2, 3 is not attacking anyone. Right? 2, 3 is not. Just look at the red ones, everybody. So 5, 1, and 3, 3 give us one pair. 1, 1, and 3, 3 give us another pair. And that's even 5, 1, and 3, 3. They are on a diagonal, right? Yeah, 5, 1, and 3, 3 are on a diagonal. Yep. Yes, yeah. 5, 1, and 3, 3 are on a diagonal. Sorry, I was confused with something else. So this is one pair, this is one pair. So totally 2 pairs are there. Yeah, the 2 pairs are there. That's the answer. 2 pairs are there. And yeah, correct. So overall 2 pairs. Again, they've given a very simple example, not too helpful to us, but it's a very simple example. All right. So basically, if there are n, so what we are getting so far is pair of bishops attacking each other. Attacking each other. So what I've got from myself so far here is, if n bishops on a diagonal, then they contribute NC2 pairs. Right, everybody? Is that clear? Okay. So how do we solve this problem? How do we actually kind of solve this problem? How do you go about solving this problem then? For each cell, go right, up, left, down, and count the number of bishops on that diagonal, then do NC2. Okay, cool. So the brute force approach, if I have to figure out the brute force approach over here, so brute force, the simplest approach would be basically create a 2D array, place the bishops. For each cell, go, right, up, or left, down, you said, right? But left, down. There's also the other diagonal, by the way. Every cell is part of 2 diagonals. They're like, southwest to northeast. So that's one diagonal, southwest to northeast. There's another diagonal which is southeast to northwest, right? So both of those diagonals will be there, southwest to northeast and southeast to northwest, right? So both those diagonals are going to be there. So you have to check for both diagonals. For each cell, go right, up, or left, down, and check the number of bishops on diagonal. Do NC2. Okay. All right. So what do you estimate will be the order of this one, given, let's say, given a chessboard of M cross M. So given chessboard of M cross M, what's going to be, and there are how many bishops that are there? There could be the number of bishops n. So we should not have taken n here, but let's say, so the bishops, one second. If n bishops, let me just make it as k, just so that we are all on the same page. This is KC2 pairs, and we'll do KC2 here. Okay. So given a chessboard of M cross M, and n is less than or equal to M cross M, where n is the number of bishops. So what's the order of this approach over here, everybody? Okay, somebody saying order M square. Somebody saying order M into N. Okay, all right. Order M square into M. Okay, so couple of ways to basically think of the order. So if I had to estimate it, basically what I'm trying to say is I'm trying to go through all diagonals, right? I'm not actually trying to go through all the rows and columns. I want to exhaust all the diagonals, right? So if I want to exhaust all diagonals, correct? This is my main thing, right? And if I do it properly, I can go through the array in a very smart fashion, such that I don't actually end up, double checking. For example, if I traverse in this kind of a way, where is my, yeah. So if I end up traversing in this kind of a way, that in the first case, somehow if I figure out that I can traverse like this, 0, 0, right? So let's first of all try to figure out these kind of diagonals. Then this diagonal here, right? So I do it here, then this diagonal like this, right? So if I make sure that I'm traversing the diagonals properly, right, one by one, then checking each diagonal in this way will be how many numbers? I'll end up just checking the entire array. So it's going to be order m square. It's going to be order m square, correct? So I'll check it. Basically, it's going to be order m square, which is order n, but we don't care about the n right now. I'm saying order m square at this point, right? After I've done with checking these diagonals, I'll come the other way. I'll check these diagonals, right? I'll check like this, then I'll check like this, right? And then I'll check like this, and then I'll check this diagonal, and so on. So it'll be like 2 into m square. 2 into m square is what I'm going to get, because I'm going to check first, slanted in one way, basically your 45-degree angles, and then your 135-degree angles diagonals. I'm going to check every time, right? So it's going to be 2 into m square, which comes down to m square itself. Is everybody getting that, right? What I just said over here? All right, and then everything also KC2 complexity. It's a constant operation, right? Almost, because n into n minus 1 by 2 is what KC2 is. So I don't think you'll face any issues there. Yeah. Okay. So in terms of, so I want to exhaust all diagonals here. One second, it came out like that. Hold on. So I want to exhaust all diagonals. Can be done in order m into m. Now the thing is order m into m okay with us? That's another thing. So let's just try to check m. What is m over here? So m is 300. So m into m will be what? 90,000, right? 9 into 10 raised to 4, basically. Yeah. So it's going to be 9 into 10 raised to 4, which is fine. Like, it's not really causing us any issues at this point. Yeah. So this is okay. This is okay. Can we do better than this though? Can we kind of do a little bit better than this? How to find time complexity? Well, time complexity is basically just the number of operations that you do. So depending on the number of operations, you can find the time complexity. Here we'll go through m square numbers twice. So that's why it's m square. So can we do better than this though? Has everybody understood the issue? Like, there's no issue as such. Like, you can even continue with this as such. It'll just be very implementation heavy. But can we do something better over here? Okay, and if we can, tell me what can we do? So it can be done in order m into m, time complexity, time, and here the space is also order m into m. Somebody saying only check the diagonals which contain bishop. How do we know which diagonals contain the bishop? By taking each coordinate given. Okay, so we take the coordinate, but again, how do I know which diagonals contain it? I'll have to again go through the diagonals to figure out if they have it or not, right? Okay, what I want you to do is, and this is why you should do your rough work, I want you to just observe the diagonals. So I've made the diagonals out over here. Just once observe the diagonals and see, can we do something else over here to figure out? Yeah, okay, somebody's got the answer. Good one, Deepika, I think. Good answer. But yeah, do the diagonals have a particular pattern? Can I say something about the diagonals. So these are the 45 degrees diagonals. What can I say about the diagonals over here? Any bishop or any number that lies on a diagonal, its coordinate sum is the same. So you have 2, 0, 1, 1, 0, 2. So the coordinate sum is the same over here, right? 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. Same sum. Same thing as 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6. All of them coming to the same sum. So anytime any bishops are on the same diagonal, they are getting the same sum. So this is for our 45 degree, right? For a 45 degree, if they are on the same diagonal, then the sum is the same, right? What about the 135 degree diagonal? This is for the 45 degree, but what about the 135 degree? Yes, very good. So over there, the difference is the same. Over there, the difference is the same. So if I take those diagonals over here, let me just take them over here, let's say. Here, 0, 7, I can do like 7 minus 0. Here, this would be 1, 7, let's say. So if I take this one, let's say I make this, the difference is 7. Here, the difference is always 6. Here, the difference is always 5. Here, the difference is always 4. Here, the difference is always 3. Right? And so on. Right? I keep getting the same difference here. What does that tell us? What does that tell us? So the thing is, if I give you two bishops, okay, let me just take some two random coordinates. Okay, so if I give you two bishops right here, let's say I give you the bishop 1, 4, and let's say 2, 3. Do they lie on the same diagonal? Can you just tell me without even putting them on a 2D grid? Can you tell me without putting on a 2D grid, do they lie on the same diagonal? Right? Lie on same diagonal. Because the sum is 5. Okay. All right. What about 5, 5 and let's say sorry, 5, 0 and 6, 1. Do they lie on same diagonal? They lie on the same diagonal, but in the 135 degree one, right? So let's just look at both of them, 1, 4 and 2, 3. If I look at 1, 4 and 2, 3, this is the diagonal which they're lying on. 1, 4 and 2, 3. See, they're lying on the same diagonal. 1, 4 and 2, 3 over here, right? But when it comes to what is the other one that we had mentioned? So this is 1, 4 and 2, 3. And the other one was 5, 0 and 6, 1. So I have 5, 0 over here and 6, 1. They're on the 135 degree one. 5, 0 and 6, 1. They're on the 135 degree one. So just by looking at what happened here? Yeah. So just by looking at the coordinates, I can tell whether they are on the same diagonal or not. Right? Does everybody understand this? Is that clear? Right? So what I could do is, right? Okay, just 1 second, everybody. Somebody's at my home. Just give me 1 second. I'll just be back. All right, sorry for that, everybody. But yeah, as I was saying, if we can just figure out the sum or the difference, right? Then we can basically store on which diagonal they are. Alternatively, the easier thing for you to do is basically create the frequency at which we get bishops on the sum diagonal and the minus diagonal. Okay. Meaning that because what we want to do is we want to find out how many bishops are there on the 45 degree or the 135 degree. We want to find out how many bishops are there. So in the sum diagonal, if we are able to figure out that, okay, in the +3, that is wherever the sum is +3, we got 5 such pairs or 5 such bishops. We got 5 such bishops that are on the +3. What does that mean? We got, this is the diagonal. There can't be 5, there will be possibly 4. We got 4 bishops having coordinates +3, meaning that go to +3 and make it, go to the +3 diagonal and just add like 4, the frequency of bishops that come there are 4. Okay, what about the -1? Again, the same thing. And again, -1 doesn't mean it's always minus. We'll do x minus y. So in this case, it'll be 0 minus 6, it'll be 1 minus 7 here. But if I do it over here, it'll be 3 minus 1, 4 minus 2, 5 minus 3. So one will be like a plus diagonal, one will be like a minus diagonal. We take the sum of the coordinates. We take the sum of the coordinates over there, and we try to see if they are on the same diagonal or not. For that diagonal, we'll increase the frequency of elements. For that particular diagonal, we'll just increase the frequency. Is everybody getting the logic over here? What we're trying to do? Is everybody trying to get the, is everybody getting the logic? Right. So what we'll do is, for each bishop, right, take x plus y, right, and increase frequency of 45 angle, right, 45-degree diagonal. X minus y and increase frequency of 135-degree diagonal. All right. Then for each of these, just figure out the NC2. For each of these, just end up figuring out the NC2 and take the sum of all of the NC2s. Okay, does that make sense, everybody? All right, take sum of each, that will be the final answer. Well, very quickly go to the implementation of this one. So that you guys want me to implement it, or you'll implement it yourself? What do you guys say? Please tell me, accordingly I'll do that. You want to do it yourself? Got the logic, everybody? You want to do it yourself? Please take another question. Sure, I'll take another question. Okay, what about others? We'll try to do it. Okay, super. So you guys will try to do it. Awesome. Great, good to know. So we have time for another question. Let me just take another question then. All right, so this is quite a difficult question, right? So let me just pick up another question, basically another difficult one. Somebody saying implement it. Don't worry, please try out implementing it yourself. And if you're not able to, I'll definitely take it up tomorrow. We'll have a longer session tomorrow, don't worry. Yeah, I'll definitely take it up tomorrow. I just want you to try it once. As I've said earlier, HackWithInfy is such that you should try it yourself once. If you're not able to try it, then you will not learn as much from it. Like if I just implement it, you'll not be able to learn. Strong prime, can you explain it? So was strong prime not done in I think in the last couple of classes it was done, right? Could you all just remind me if it was done or not, the strong primes? Has it been discussed? Not yet? Okay. Fair enough. So tomorrow for sure, I think I'll just take it in my class for tomorrow for sure. So, and you guys are all well versed with sieve, right? The sieve over Eratosthenes. Are you guys all well versed with that? So, okay. So tomorrow we'll take up strong primes. I'm just writing down. Strong primes is one of them. We'll implement the bishop one if needed. So strong primes is one of them for sure. We'll also take up this particle simulation one. Right. That's what we'll do. All right, fair enough. So cool. So these two definitely we'll do tomorrow. I think we'll have, that's the time we'll have, but or we'll take up more also as and when you guys want, right? Somebody was saying minimum string rotations. Minimum string rotations. Although I think I've done that at some point, but yeah. Cool. Let's come back to this question, which is particle simulation. Okay. Okay. So in particle simulation, the question goes like this. We are given an array of particles. Each particle has a positive size greater than 0. So it's all positive particles. Any two particles can combine and produce a new particle whose size is the absolute difference of the combined particle, possibly 0. The old particles which combined have now vanished because they all combined. This new particle can combine with any other particles. If particles are allowed to combine in any way, what is the minimum particle size obtainable? Note that the combined particle size can never be lesser than 0. Okay. So they give you an example here, and we'll take that example. So the example is basically as follows over here. Just give me 1 second. Yeah. So this is the example. Let's say particle simulation. Right. So this is the particle. Basically, any two particles can combine and give another particle, which is the absolute difference of these two. Okay. So you'll take always the absolute difference. For example, 30 and 27 can combine and they will give you 3, 26, 10, and 6. Now 3 can combine with 6 and give us again 3, right? So what I did here was I took basically 30 and 27, these two combined here. I'm randomly combining them. And it's saying that you can randomly combine however you want. There's no problem. Right? So you got 3, 26, 10, and 6. And let's say I combine 3 and 6, let's say, for whatever reason, I did that. And I got again 3. And, I got again 3. I got 26. And then I got 10. And, I could combine 10 with, let's say, 26. I could get, and there's no need to continuously combine. I'm just giving an example. So it'll be 3 and 16. And if I combine these, I'll get 13. So if I go around this logic, I will get 13 as the minimum possible particle. Whereas I don't like, technically 3 was the minimum possible particle. The question is not to finish all the particles. Remember that? Question is not to finish all the particles. Question is, you keep doing something. If you get a minimum possible particle, let's say you get 0, then you can stop there also. So try to get the minimum possible particle in the entire thing. So just to give you an example, let's say, for instance, I had 30, 27, 26, 10, and 6, and add another 6. What is the minimum possible particle? I would combine 6 and 6. I would get 10 and 0. There's no point in combining any other particles. I already got the minimum possible. So the answer is 0. That's the minimum possible particle. Does that make sense, everybody? Does this make sense? Okay. So if I further do it for this question, what is the minimum possible particle that you can get? 30, 27, 26, 10, and 6. What's the minimum possible particle that I can get? I could combine 27 and 26 and get 1. So 1 is already on the cards over here, right? 1 is already on the cards. We should try to see if we can get even lesser than 1, which is only 0 is possible. So 1 is already there. How 1 is there? 27 minus 26 will give me 1. So that possibility I already have. Any other kind of possibility I can do? Any other possibility that you guys have? I could do 27 minus 26. I could basically just take 27, 26 and get 1. Very good. Somebody saying, sir, why don't you take 30? Okay. Somebody saying 30, 16. Okay, got it. Yeah. So we're saying take 30 and 26. So first you combine 30 and 26. First you combine 30 and 26. What will you get? You'll end up getting 4, right? So you got one particle 4 over here. And then you get 27, 10, and 6, right? This is what's remaining. Then you combine 10 and 6, and you'll get 4, 27, 10, and 6. Sorry, 4, 27, and 4 over here, right? And finally, among that 4 and 4, you can get 0 and 27. So 0 is the minimum possible particle. So I can actually reduce this down to a 0. Right? Are you guys getting this? Right. It's a tough question. It's a tough question because first of all, we don't know how many times we should combine. We don't know which two particles, if you combine in which way, can later on give another particle or not, right? Like in the initial, we chose 30 and 26, and we chose 10 and 6, which gave us 4 and 4, and then give us 0, right? That's what we did over here. We chose it like that. Had I chosen 30 and 27 earlier, then I would not have got a 4 and I would not have been able to get there. Right, guys? So, any thoughts on the approach for this question? Any particular thoughts? Anything you guys are thinking of? We'll just discuss possible approaches, right? Just discuss possible approaches. I'll not discuss the solution. Guys, think over it. We'll come tomorrow and discuss the solution. We have about 10 minutes. I just want your possible approaches over here. Can you please explain another test case? Sure thing. So somebody's saying DP. I don't really worry if it's DP or not DP and so on. Let's have a discussion, right? Could be DP, could not be DP also. That's fine. But let's just have a discussion. So heaps, okay, fair enough. Probably, yeah, you might need a minimum and all. We don't know. Could be. Okay, another example here, just to tell you all, right? What is the minimum that I can reach through these set of particles? What's the minimum number I can reach through these set of particles? What's the minimum I can reach? Somebody saying 5. Okay, can you guys tell me the path also of how you reach 5? Do tell me the path as well of how you're reaching 5. -35 minus 30 is 5. Okay, that's possible. Somebody saying 4. How do you reach 4? So somebody reached it like this by saying 75 minus 40 is 35, and then minus 30, right? So which is equal to 5. So that's one approach. Okay, 5. Can anybody come with another approach? Somebody saying 4. How did you guys reach 4? Is 4 possible here? Okay, very nice. Somebody saying 101 minus 75 will give me 34. I don't think is the maths correct? Maths is not correct there. This is 26, boss. It's not 34. Right? But yeah, you're on the right track. Then 30 minus 26 will give me 4. Right? So 101 minus 75 will give me 26, and that 26 can combine with 30 to give me 4. Okay. Can I go even further down than 4? Can I go anything lesser than 4 is possible? Anywhere? If you can't find, then that's fine. But anything lesser than 4, you guys think? Not possible less than 4. Somebody saying not possible less than 4. Others? Any? You guys agree? Not possible less than 4. So yeah, good thing is this question has given you one more option, and yeah, there's not possible less than 4. It is 4 only. It can't be less than 4. Okay. Any thoughts, everybody, on how we can go about solving this? Any thoughts on this one? Any particular thoughts on how to solve this question? Heaps. Okay. What will you do with heaps? What will you do with heaps? Somebody saying. I'm not saying you have the right answer. I'm just generally asking, like, what do you think where the heaps could be used? Where do you think heaps could be used over here? Others? Any thought? If you have no idea, you can say no idea also. That's fine. Insert all elements in max heap and pop the top two elements and insert absolute a minus b in heap until size is 1. Okay, but does that really work out in our case? Did that really help us out every time? Because if you see, if you try to do that, how did that work out here? So if I would have done it here, let's say it would have come to 101 minus 75, which would have given me 26, right? So now the max heap would be 40, 30, and 26, right? That's what the max heap would be like. Then I do 40 minus 30, which would give me 10, right? So then my max heap would be 26 and 10, and then I do 26 minus 10, which would give me 16. So I'm not really getting anything, right? Like I'm getting 16, whereas we saw that it could be 4. So heap is not really helping out in that sense, right? That's why taking examples is very good, because we took the example. So now we know that the heaps is not going to help us out as such over here. Okay, dpl, r dpl, k plus k plus. So you want to explore all the dp states. Just think of it. If you try to explore all the dp states, what's the possibility of all the dp states? Will it not be like 3 raised to n or something? Like just try to think of the dp states. If you want to do, just think of how many dp states you'll have, because you're going to have tons and tons, right? And if you just look at the constraints, it says that n is 100 and the array is 10 raised to 4. So we will memorize. Yeah, I can understand, but how much will you memorize? Is what I'm saying. Means that much space also you should have to memorize, no? Is what I'm saying. So you'll have to end up memorizing how much? Like it's saying n is up to 100. You have 100 elements, and AI itself is 10 raised to 4. Now, as per what you have said, if I have to look at it correctly, L comma K plus K plus 1 R plus. Try to estimate how much that would take. First of all, if that state is even correct, and if yes, how much that would take. Try to estimate. I think that will be a lot, right? So there is some DP involved. I'm not saying, I'll give you guys a hint for sure that it's somewhere DP is involved. But what kind of DP? What do you do with the DP here? That's the important part. Okay, somebody's saying sorting it and subtracting from two maximum numbers. So I think we just saw the example and that won't really work out, right? As per that example. So storing all the differences in DP. Okay, so there will be like NC2 differences, I guess. You store all the differences, and then what? Then the next time you'll again store all. Which difference will you choose then? For each NC2 difference, will you again choose another NC2 differences? That will grow exponentially, right? Think again. I'm not trying to put you down. I'm trying to think. I'm trying to get you guys to think. Think about this. All right, you guys want some more time to think about it? Will you guys think about this today? We're going to cover this up for tomorrow for sure. But are you all going to think of it today? This question? Today, tomorrow, are you guys going to spend some time and think about this? Right, so this question is available to everybody on the HackWithInfy pack. Right, it is available to everyone. Okay, you'll definitely try. Is everybody giving me that commitment? Are you all going to try this question out particle simulation? Any hints? Okay, very good. Final. Thanks for asking. I was waiting till when you guys will ask for the hint. All right. So the major hint that I'd like to give you is it is not really path dependent, is what I'd say. Don't try to figure out the path it will take to the minimum, but try to understand, finally speaking, what does the number look like? That's kind of all I can say. But basically, like, don't try to figure out at each point which is the best number to choose to minimize the difference further. Mathematically, there is no way that you can figure this out. Okay. Mathematically, if you're trying to figure out that, okay, these two numbers will lead to the best ones later on, there's no way. That's why we can't go for a heaps way, because there is no deterministic way of choosing the right number over here. Like for 37, for 30, I should choose 27, or for 30, I should choose 26, and for 10, I should choose 6. There is no way, like there is no formula that can tell you this. For that matter, you could have even gone 30, 10, 26, and 6. So 30, 10 would give you 20, 26, 6 would have given you 20, and we have still got to 0. Right? So it's not really dependent on the path. So don't try to figure out the best numbers that you can choose. For each number, so this question is not about, for this number, I'll choose this as the next number. No. The question is, what is the minimum I can get to? So for the minimum, try to see that when I arrive at that minimum number will be a combination of some numbers, right? What is the way that I can generate those combinations? And then can I use DP to memorize those combinations? All right. That's the biggest thing that I'll tell you. Okay. What is the kind of combinations that I can get? And is that DP is there to memorize those combinations or not? So DP will come separately. But first, can I even get a set of combinations over here? That's what I'll be looking at. All right. That's the thing. You can rewind and just check this part a little bit later on also about what is meant by this. Okay. Cool. All right. So can you guys give me a quick recap of what all we've covered today? Can this type of question be repeated in HackWithInfy? Similar question could come. I don't know if the same one will come. Same one is very unlikely, but similar one could come. All right. So recap, everybody. What are the things that we covered today? Can you all tell me? Yeah, previous year's questions, but which questions? K big is the one we started with. Pair of bishops. And finally, particle simulation. Cool. So that's all we did for today. Everybody, will continue the discussion in tomorrow's class. I hope that was useful to all of you. Cool. That's it from our side, everyone. Thanks a lot for joining in today. If you liked this session, please do go to the YouTube channel. We've been streaming this there as well. Do subscribe over there. Hit the like button so other people can also find this session. And if you have any specific question you want us to discuss tomorrow, please reach out to us at team@edyst.com. I'll make sure that it will be discussed tomorrow. We'll do a big marathon session tomorrow. So team@edyst.com. Email us for any specific queries. Right? That is, if you want a specific question that you want me to cover tomorrow, just put it here. Happy to do it. Just make sure that you put it here as well. All right, everybody. Thank you all for joining in today. It's been a long time, so glad to see all of you today. And I'll catch you all next time. Thank you so much.